Hello viewers, in today's session we are going to discuss another important mixed problem from limits and integration, right? So we have already discussed these kind of problems in our earlier videos. So here we have to find out the value of this expression in which we have limit n tends to infinity, and we have the integral from 3n to 5n, and the integrand is x plus 4 divided by x square plus 1 dx, right? So let us start, and let us first quickly see two important results which are going to be used while evaluating this integral, right? So the first important result is that the integral, that is f prime of x over f of x dx, is always equal to the log of f of x, right? So if we have an integrand in which the numerator is the derivative of denominator, then the value of this indefinite integral is equal to the natural log of f of x, right? And the second important result is that the integral 1 over x square plus 1 dx is equal to tan inverse x, right? So to start with, what we will do, we'll first calculate the indefinite integral, that is x plus 4 over x square plus 1 dx, utilizing these two important results, right? So here what we will do, let us write this integral as a sum of two integrals. So we'll write x over x square plus 1 dx, and then here we can write 4 over x square plus 1 dx, right? So now let us multiply the numerator by 2 and divide here by 2. So we have half, and here we have 2x over x square plus 1 dx, right? And here taking 4 outside the integral, we have 4 and dx over x square plus 1, right? Now see here, the denominator is x square plus 1, and the derivative of x square plus 1 is equal to 2x, because the derivative of 1 is 0 and the derivative of x square is 2x, right? And 2x is present in the numerator, right? So we can use this result, because here we have f of x, which is x square plus 1, and f prime of x is equal to 2x, right? So to get the derivative of x square plus 1 as 2x, we have multiplied the numerator by 2, and we have divided the denominator by 2, right? So now the value of this integral is a log of x square plus 1, because x square plus 1 is f of x, right? And here the integral dx over x square plus 1 is a standard result in indefinite integral, that is equal to tan inverse of x, right? So the value of this indefinite integral is half log x square plus 1 plus 4 tan inverse x. So now let us call this expression as say p, right? So now p can be written as limit n tends to infinity, and we can now write here half log x square plus 1, and here we have 4 tan inverse x, and we can now take the limits here, 3n to 5n, right? So now applying the properties of definite integrals by substituting the limits for x and taking the difference. So first we'll take 5n. So we have limit n tends to infinity, and we have half log of x square. So here we have 5n square. So 5n square is 25n square plus 1. Then we have 4 tan inverse of 5n, right? So this is the first expression, and then we can take x is equal to 3n. So we have here half, then we have log, and for x we can now write 3n. So 3n square is 9n square plus 1, and then we have here 4 times the tan inverse of 3n, right? So now we have these two expressions. Now we can collect the similar terms here. So we can now write limit n tends to infinity, and we have first half log 25n square plus 1 minus half log 9n square plus 1, right? So this is the first expression collecting the log terms here, and then the tan inverse term can be collected here. So we have 4, and then we have tan inverse of 5n minus tan inverse of 3n, right? So now we have this expression. So now here using the properties of log, we can use this property that is log of a minus log of b is equal to a log of a over b, right? So here we have now p is equal to a limit n tends to infinity, and we have here half. We can take half common, then we have log of 25n square plus 1 minus log of n square plus 1. So this is a, this is b. So we can now write log of 25n square plus 1 divided by 9n square plus 1, right? And then we have plus 4 here, and we have tan inverse of 5n minus tan inverse of 3n, right? So now here we have limit n tends to infinity. So what we will do, we'll apply the limit to this term and this term individually, right? So let us first take this one. So we can now write a limit n tends to infinity, and now we can divide the numerator and denominator by n square. So we'll write like this, half log, and here we have 25n square plus 1 divided by n square divided by 9n square plus 1 divided by n square, right? So dividing the numerator and denominator by n square, right? So because we know that when n tends to infinity, then 1 over n tends to 0, and further 1 over n square tends to 0, right? Okay, and here we have 4 and tan inverse 5n minus tan inverse 3n, right? Okay, so now we can write limit n tends to infinity, and here we have half. We are going step by step. So now distributing n square over 25n square and 1. So we have simply 25 plus 1 over n square, right? Here n square and n square get cancelled. Similar is the case with this one. Here n square and n square get cancelled. So we have 9 plus 1 over n square, right? Okay, and here we can now write 4 times tan inverse 5n minus tan inverse 3n. Okay, now let us take the limit n tends to infinity. So when n tends to infinity, 1 over n tends to 0, and 1 over n square also tends to 0, right? So the higher powers of n which appears in the denominator, then 1 over n raised to the higher power must tend to 0. So here this term is 0 and this term is 0, right? So we have here 0, this term is 0, this term is 0, and when n tends to infinity, then 5n also tends to infinity, right? And similarly, when 3n also tends to infinity, right? So when n tends to infinity, 5n tends to infinity, then it implies that tan inverse of 5n tends to tan inverse infinity, right? And tan inverse infinity tends to pi over 2, because we know that tan of pi by 2 is not defined, right? Okay, when n tends to infinity, 3n tends to infinity, and tan inverse 3n also tends to tan inverse infinity, right? Because 3n tends to infinity and tan inverse infinity tends to pi by 2, right? So here we have pi by 2 and here also we have pi by 2. So now this expression, which is p, we can now write when we take the limit n tends to infinity. Here we have half and we have log, and this is 25, and here 1 over n square is 0, so we have 0, and here we have 9 plus 0, right? And here we have plus 4, and tan inverse 5n is pi by 2, and tan inverse 3n is also equal to pi by 2. So now we can write this expression as half log 25 over n 9, right? Because pi by 2 minus pi by 2 is 0. So here we have 4 times 0, that is equal to 0. So this term becomes 0. So we are left with only half log 25 over 9, right? We can also write it like this: half log, and 25 over 9 can be written as 5 by 2, 5 by 3, sorry, this is 5 by 3 square, right? And using the properties of log, that is log a raised to m is equal to m log a. So here we can now write half times 2. We can take this 2 in front of this log symbol, so we have half times 2 log 5 over 3. So this 2 and this 2 get cancelled, so we are left with p is equal to a log of 5 over 3, right? So here we can also use the symbol, that is ln, for the natural log, so we can also write it as ln 5 over 3, right? So here's the value of this expression is equal to the natural log of 5 over 3.